Okay, okay, class. Today we're going to talk about concentrations, and we're going to go over some problems for you to practice these skills that are taught in this chapter, which is chapter 8. And so we've already discussed what solutions are, solute and solvent, and here's some terminology you may want to familiarize yourself with. But now we're going to talk about concentrations. Okay, so concentration is defined as the amount of solute dissolved in a certain amount of solvent. So a solution is a solute dissolved into a solvent, but the concentration is the measure of how much solute is dissolved in a given amount of solvent. And solubility is the limit of how much solute can be dissolved in a given amount of solvent, the limit. And so we know that sodium chloride has a certain limit of solubility in water. We know that sucrose, table sugar, has a certain solubility in water to where no more can go into a given volume. And for instance, here certain solubilities of various solutes in water at 25 degrees Celsius, because as we know, when you increase the temperature, solubility tends to increase. Okay, and so water is polar. And so as you would expect, the nonpolar solutes should have a very low solubility, and that's what you see in benzene, which is nonpolar, methane that is nonpolar, and you should see a great solubility on those with those molecules that are very polar, okay, such as or even ionic, such as calcium nitrate, sodium chloride, or sucrose right there, which is table sugar. But you're not expected to memorize all this. I just wanted to show you that each compound has its own solubility for given solvents, and this is water as the solvent in this case. Let's talk more about concentrations, okay? Saturated is a term used whenever the solution has a solute at the solubility limit. It is saturated. There's no more solute that can fit inside that volume of solvent. Unsaturated is a solution whose solute is less than the solubility limit, meaning you can still add some more solute into that solvent and it will dissolve. One way we can express concentration is called mass percent, and it's given by this formula right here. Mass of solute over mass of solution. Now keep in mind that says solution and not solute. Then what we're going to do is multiply that number times 100. There's also a volume percent, or percent VV, and it's the volume of the solute over volume of solution times 100. So that one takes into account the volumes of everything in the event that you didn't have the masses, or the mass volume percent, which kind of mixes both of them. So it's the mass of the solute over the volume of the solution, but note right here that the volume has to be given in milliliters. Okay, so grams over milliliters. So let's look at some, well actually there's one more right here, molarity. This one's incredibly important. As a chemist we use this one all the time, but molarity actually relates concentration to the mole unit that we learned back in chapter 5, stoichiometry. So molarity is the number of moles of solute over the number of liters of solution. So moles per liter. Okay, moles per liter. So that's molarity. So let's check out some of these problems. How many grams of glucose are needed to make 800 total milliliters of a 30% weight volume solution? Okay, so we're looking at weight volume, which means we are looking at mass of solute over volume of solution, volume solution, but that needs to be in milliliters, right? Times 100, and it's saying we want 30%, and so now we're trying to make 800 total milliliters, so that's actually the denominator. So then we just need to rearrange and solve for this because we need to know the mass of glucose, which is the solute, over 800 milliliters times 100 equals 30%. Okay, so I'm going to start by dividing 30 by 100 just to do some arithmetic. And so that gives us mass solute over 800 milliliters equals 0.3. Okay, now to isolate that term by itself, we're going to need to multiply both sides by 800, which would give us mass solute 0.3 times 800 milliliters equals 240 grams. Okay, now I know that those units don't match, and we're not going to worry too much about that at this point because it has to deal with this equation using mixed terms: mass of solute in grams, volume of solution in milliliters. So let's not worry too much about the units, except for it should be in grams because we're looking for the mass of the glucose. And that's exactly what you find the answer to be right there. So that's how you solve this type of problem. So that's you had to rearrange to solve for it, okay? To solve for the numerator. So isopropyl alcohol is mixed with water to produce a 30% volume solution. If 900 milliliters were made, how much isopropyl alcohol was added? Okay, so remember this is a volume percent, and so what we're looking at is volume of solute over volume solution times 100, and it equals 30%. So it's saying if isopropyl alcohol is mixed with water, so isopropyl alcohol is going to be the solute, and water is going to be the solvent, and it makes a 30% solution. Now it's saying 900 milliliters total were made, and that is a solution because it's made of the water, the solvent, and the solute, isopropyl alcohol. So now we have everything we need to set up this problem. We're looking for the volume of solute. So volume, solute, over the volume's total of solution, which is 900 milliliters, times 100 equals 30%. And so we'll do similar arithmetic to the previous problem. So we'll divide 30% by 100. Which will give you 0.3. And then we're going to multiply this term by 0.3 in order to get the volume of the solute as an isolated term. And since this is a volume percent, our units are going to be in milliliters. So the volume should be 270 milliliters. Now keep in mind, had this read 900 liters right here, then this unit would have been liters. But I just kind of matched the unit that was already given to me. Okay, and so that's exactly what we have, 270 grams of isopropyl alcohol. And if you actually wanted to figure out the constituents of that solution, we figured out that it was 270 grams of isopropyl alcohol. And actually, it shouldn't be grams. It should be milliliters, right? Milliliters of isopropyl alcohol. And since the total solution is 900 milliliters, that must mean that we added 900 minus 270 which equals 630 milliliters of water. Okay, and I'm not entirely sure why on this slide there's so many typos. That should be milliliters, and that should be milliliters right here as well. So I apologize. We're not dealing with masses, we're dealing with volumes as per that. Okay. Calculate the molarity of 0.730 moles of NaCl in 2 liters. So molarity equals moles solute over liters solution. And so that's 0.730 moles over 2.00 liters, which will give you 0.365 molarity. Calculate the molarity of 2.1 moles of magnesium oxide in 850 milliliters of solution. Okay, so we have 2.1 moles of MgO. Now be careful here, that says 850 milliliters, so we're going to need to divide by 1,000 to get liters, because it's moles per liter, right? So it's going to be 0.850 liters, so moles per liter equals molarity. Molarity, by the way, is denoted as a capital M, okay? and that'll get you 2.47 molar. Molar is how we say it. So 2.47 molar is the molarity. How many moles of NaOH are present in 11.8 liters of a 0.410 molar solution? And so we know it's going to be moles of NaOH over 11.8 liters. That's just bad, isn't it? Equals 0.410 molar. And so we're just simply going to multiply that over there in order to isolate that term. So 0.410 molar times 11.8 liters equals whatever is behind the black box. There you have it, 4.84 moles. Okay, and you can actually back check your work. Does 4.84 moles over 11.8 liters equals 0.410? It should, so go ahead and double check that. And we'll be off to dilution in the next video. Have a great day.